Good morning everyone. In the given circuit, the AC source has angular frequency equal to 100 radian per second. Considering the inductor and capacitor to be ideal, what will be the current I flowing through the circuit? In the given circuit diagram, the upper part of the circuit contains one capacitor and one resistor. The lower part of the circuit contains one inductor and one resistor. So basically, upper part of the circuit is a capacitive circuit and lower part of the circuit is an inductive circuit. The two parallel circuits are connected to a common source of AC supply of 200 volt, and we have to find out current I in the circuit. At this node, current gets divided into two parts. Let us say upper part contains IC and lower part contains IL. Since these two currents have a phase difference between them, so we cannot simply add them. Now let us take the upper part of the circuit. The capacitive reactance is 1 upon omega C. Omega is given to us 100 radian per second and capacitance is 100 microfarad. So this is 100 into 10 raised to the power minus 6 farad, and this is equal to 100 ohm. So impedance of the upper part of the circuit, root of R square plus XC square. Resistance of upper part is 100 ohm. XC is also 100 ohm, we just found. So this gives us impedance equal to 100 root 2 ohm. So now we can find out current in the upper part of the circuit, IC. RMS voltage is given to us upon impedance. 200 volt upon impedance is 100 root 2 ohm. This is equal to root 2 ampere. Since upper part of the circuit is a capacitive circuit, so in this case current will lead the voltage. In this case 10 phi is equal to XC upon resistance R. XC is 100 ohm and resistance is also 100 ohm. This is equal to 1. So this gives us phi equal to 45 degree. Now let us come to the lower part of the circuit. Inductive reactance XL is equal to omega L. Omega is 100 radian per second. Inductance is 0.5 Henry. So XL is equal to 50 ohm. So now we can find out impedance of the lower circuit. This is equal to root of R square plus XL square. Resistance is 50 ohm. XL we just found 50 ohm. So this is equal to 50 root 2 ohm. So current in the lower part of the circuit is this is IL. RMS voltage upon impedance. RMS voltage is input voltage given to us 200 volt, and this is impedance is 50 root 2. So current in the lower part of the circuit IL is 2 root 2 ampere. Since lower part of the circuit is an inductive circuit, so in this case current will lag the voltage. So in this case tan phi is equal to XL upon resistance R. XL is 50 ohm and resistance is also 50 ohm. So this is equal to 1. So tan phi is equal to 1. This gives us phi equal to 45 degree. Now let us find out phase difference between the two currents. Voltage is common here. In the upper part of the circuit, which is a capacitive circuit, current leads the voltage by 45 degree, and this current is root 2 ampere. The lower part of the circuit is an inductive circuit and current lags the voltage by 45 degree, and IL is 2 root 2 ampere. So phase difference between the two currents is 90 degree. So now we can find out current I. This is equal to root of IC square plus IL square. IC is root 2 ampere and IL is 2 root 2 ampere, and this is equal to root of 2 plus 8, and this is root of 10, and this is approximately equal to 3.16 ampere. So therefore option B is correct. Alright, thank you very much.